So we've got the y equal t squared function. Here's a graph, but the question that we're looking at doesn't directly ask you to graph anything, okay? But here's the graph to look at so we can refer to it. Y equals f of t equals t squared then, okay? And we're going to vertically stretch by factor 0.015. Now, 0.015 is a small factor. Let's just say we were vertically stretching it by factor 2. What's that mean? That means every point moves twice as far from the x-axis, right? So this point will move up to here. You know, you get a little arrow from here to here, and you double that arrow, you get an arrow that goes from here to here, and there's your point, right? Remember doing that?
Yeah.
Okay. And then here, well, you get an arrow from here to here representing your distance from the x-axis, or your displacement from the x-axis, and you double that arrow, and you're going to be up here. So among other things, this point moves further than this point because it's already further away, and you're doubling its distance, right? If it's a greater distance, when you double it, you're going to end up moving it more than you would a point that's closer. And that's a concept you really need to understand. Okay, so you got y equals f of t equals t squared. In order to vertically stretch by factor 2, you would multiply every y value by 2, right?
Yeah.
So instead of getting f of t, you would get 2f of t, and that would be 2t squared, right? So if you move every point twice as far from the axis, your function is going to become 2f of t, or 2t squared. Okay, and you would have then a graph of 2t squared. Well, here we're multiplying by factor 0.015. Now that's like 1/60th, right? Okay, so if you multiply this y value by 0.015, you're going to get a little small y value here. Okay, and this y value is going to shrink down so much that you can't even see that it's different from the x-axis, right? That the point is away from the x-axis. So you would rescale the graph. But the point is then, if you multiply all your y values by 0.015, your function becomes 0.015 f of t, right? Because these are your original y values. F of t represents the original y value, and you vertically stretch by 0.015, you multiply that y value by 0.015. Now you might want to review what we did when we made tables for vertically stretched functions and so forth, okay? In any case, then your function is going to become 0.015 t squared, okay?
So you want to see it, I'm just asking, you want to see it like far as y equals whatever the value is, the factor,
Right.
and the original,
Yeah.
then you want to see the new
Yeah,
part.
because you're multiplying all your t squared values by 0.015, that gives you 0.015 t squared. Very easy to write out, okay? But of course you also need to do it graphically, but for 0.015, I'm not going to ask you to do that because that's such a drastic factor, you're going to have trouble locating your points, okay? If I said vertically stretched by factor 2, I would expect you to be able to do it, okay? The way we did it with the arrows and stuff. And we'll talk more about that.